and gentlemen, let us introduce you to Jonathan Knowles, Explorer in Residence at Autodesk. Jonathan explores the frontier of beyond the horizon technologies, providing insight on the evolving role of applied innovation. He's a creative thinker who researches the intersection of technology and global trends, bringing the arts and science together while connecting people and ideas. A futurist and innovator, he collaborates with engineers, scientists, designers, educators, and others seeking to imagine, design, and create a better world. A respected voice on future trends, long-range vision, and creating the preferred future, Jonathan counsels startups, global business leaders, policymakers, and Tier 1 academics around the world. With a focus on ocean science, climate change, space systems, robotics, biotechnology, archaeology, and paleoanthropology, he participates in fieldwork with others across the globe to help understand and preserve our past and solve some of the world's most complex challenges. Please welcome Jonathan Knowles.
So, Nam Kelekili. Cape Town, South Africa. Sorry, that's as much of my quotes as I've been able to learn this morning. Welcome to AU South Africa. My name is Jonathan Knowles, and I am in the office of the Chief Technology Officer, the CTO at Autodesk. And it is absolutely my pleasure to be here spending the day with you in such a beautiful place as Cape Town. Well done on this amazing, amazing part of the world. And we are just super excited to have you here for an incredible day of networking and learning and inspiration. Now, I'm going to talk to you about the future of design, the future of construction, the future of manufacturing, and the future of media and entertainment. And I'm going to talk about the future of making things and what that means for you and for your business. So first of all, it means supporting you, the people who design and engineer incredible things, the most high-performance cars, towering skyscrapers, the smartest devices, and the greatest, most compelling films. And you're doing all of that using Autodesk software, and thank you for that, by the way. Worldwide, there are more than 200 million of you, design professionals, engineers, and architects, digital artists, and students, and hobbyists who use Autodesk software to unlock your creativity and solve important design, business, and environmental challenges. Agility, mobility, connection, that's what the world's all about. Cloud computing, mobile computing, social connection, and collaboration. These are the technologies that will dominate the years to come. And if you're not already using these technologies, you're missing out. You're already behind. But don't worry, Autodesk will be here to help make sure you have the tools to leverage these powerful technologies. And fueled by these technologies, in this new future of making things, industries are learning from each other like never before. Now, creating a building is often like building a product. Let's take a look at this together. There's a company near Autodesk's headquarters in California called ConX Tech. Its founders wanted to reinvent the way steel-framed buildings are designed and built. They came up with a clever system for attaching steel beams to engineered columns. The system is based on this dovetail joint where each beam just slides into place and is bolted in. And that means there's no welding or riveting on the job site. And their system is also cheaper to make and cheaper to build. And they have this jig that allows them to weld brackets on horizontally, which is 30% faster than welding vertically in the field. And their precision is in the thousands. What's most clever about this system is how quickly and accurately the buildings go up. They can actually build 10,000 square feet a day. For example, this building went up in less than 7 hours using only 8 steelworkers. And this system works in harsh conditions with a very, very small crew. And here's one of their buildings. It's the Neuroscience Center on Stanford University's campus. This building was more manufactured than it was built. And it's as though they were assembling a car on a factory line, not erecting a building on a job site. Now, the ConX team, they created an open-air factory. They're assembling the structure instead of building it. And I think that's a great example of industries learning from each other and industries converging. There's something else we want to share with you today, and that's this idea that our projects, the work that we do, the works that we create, whether it's a building, a car, a video game, all adhere to the same cycle. It's a cycle of designing, making, and using. In the past, you never learned from how the thing you made was used, but now, with the technologies we have at our fingertips, and to those that are just on the horizon, we're going to be able to do just that. And we're going to show you how. You see, today, we're entering an era where the cloud, social and mobile computing are connecting teams and individuals across projects like never before. And in order to take advantage of that interconnectedness and to optimize the design and use phases of the product or the project, it's essential to go beyond simply optimizing the design. We have to optimize how the product is built, as well as the systems that interconnect with it. So now we're seeing that the digital and physical are deeply integrated throughout the entire design process. Advanced technologies in manufacturing and construction like 3D printing, microfactories, drones, and reality capture, they are becoming the norm today, like this project. As the project was initially scoped, the designers and engineers looked at scans of the site and they designed to that specific site. And now, during the build process, drones capture on a daily or weekly basis the progress of this build. And as the link between designing and making gets closer and closer, the feedback loop gets even tighter, and it becomes possible to respond to the feedback even more quickly. You see, while how things are designed and made will be changing, so will the way we work. Anyone, anywhere, on any device will be able to contribute to the project in real time. The bottom line is barriers to productivity are disappearing. This new way of working, this embracing of a new era, isn't reserved just for large businesses. The future of making, it will apply to anyone and can be just as transformative for small companies and startups as the big, accomplished companies.
My name's Alex Fleetwood and I'm the founder of Sensible Object. We're a game design studio making games that combine physical and digital play. Our first game is called Fabulous Beasts, and in it players build a physical tower in order to create a digital world. The tower rests on a smart sensing platform that translates every piece into an equivalent in a connected digital world. The aim of the game is to get the highest score before the tower falls down. I think it's a really exciting time to be investigating this relationship between games and hardware, between physical and digital play. And one of the reasons for that is that we now have a set of tools at our disposal that enable us to design, prototype and scale very rapidly. We can create and test pieces using a 3D printer, and then of course there is a sort of linking software layer which hinges the rest of that together. Tim, our product designer, is using 3D Studio Max to do the surface modeling for the pieces, and then he's translating that into Autodesk Fusion to do the solid modeling. Small independent game developers have been working in software for a long time, and I think it's started to become true over the last 5 years that that is now possible in hardware electronics as well.
Now that's the future of making things. And in this new era, the little guys are just as empowered as the large, established companies. Let's take a look at how some companies are changing the way they design, make, and use in this new era. First of all, the Ford Motor Company. They've been around for more than 100 years, and they're looking for new ways of working to help transform their business. Here's an example of that, which combines the digital and physical worlds in a way that's unique. This is Elizabeth Barron, and she founded and still runs Ford's Augmented Reality Lab.
We're here in the virtual space of the Product Development Center in Dearborn, Michigan. Here in the virtual lab, we assess high-definition renderings of the vehicle to overall improve quality and appeal of the vehicle.
In this space is a full-size virtual vehicle that we can evaluate for many different aspects. of engineering and design and look at it from the customer's perspective.
We put the head-mounted display over your eyes so that you have computer screens in front of your eyes effectively, and then we track where those are relative to this space, and then we put the CAD information over your eyes, and then we're tracking where you are relative to that CAD information, so you can walk around and interact with the entire vehicle.
And then we give you tools which are very similar to what you have in the physical world to look at the car and evaluate it for quality.
So the biggest benefit is the ability to have a realistic vehicle much, much sooner in the product development phase.
We can represent them in our software instantly to show many of the different possible combinations of builds that could come off the line, and then we can make educated decisions on whether or not this is going to be acceptable or require an engineering change.
The way we have set this up is we're able to collaborate globally. So we can have representatives who are immersed in their virtual space and we're immersed in our virtual space, and we can look at each other and talk to each other in real time on different continents inside the same model. So we have upgraded the software capability as well as the hardware capability, and so the vehicles that we see now are incredibly lifelike. We're showing that stereoscopic view in real time to a person or multiple people around the world, and then also in 4K. The level of detail that we can focus on now is amazing, and the customers see that in the end.
Now, some of you work for auto companies and you know what a challenge it is to sometimes communicate between design and engineering departments. The designers come up with some amazing look, but the engineers have to find a way to build it. And forget about marketing. Those guys just want to see what the thing's going to look like so they can sell it. But with their 5Lab and Autodesk visualization technologies, Ford's overcome that challenge. It's really helping them to bring together better cars to market sooner, and they're delighting their fans worldwide because of it. Let's take a look at another example here. As sensors are embedded in places and things, we have the opportunity to send real-time, comprehensive feedback to be incorporated into future designs and processes. And here's one of the places that's happening. It's in airplane de-icing. Now, while maybe not a big problem here in Cape Town, this is a big problem in much of the world in the wintertime. Condensation freezes on airplane mechanical parts and exterior instrumentation, and it makes the planes impossible or unsafe to fly. And in 2008, there was a large storm in Seattle 2 days before Christmas. There was a problem de-icing operations at the airport. 450 flights were canceled. 4,000 people were stranded. And this happened because they ran out of de-icing fluid. So Premier De-icers, they're the company that made and operated the trucks that ran empty that night. Well, because of what happened in Seattle, Premier De-icers questioned their whole process, the workflow, the supply chain, and all of the logistics involved. The solution they came up with was the Internet of Things for de-icing. They instrumented every component in that process. Then they aggregated all of the data produced by those sensors in one place using Autodesk's Fusion Connect software. And now, Premier has data that is critically valuable to everyone involved in that entire process. The airline can see within 7 seconds of each de-icing how long it took, how much fluid used, and how long the aircraft had to wait. And the US Environmental Protection Agency, they can get an accurate report on the amount of hazardous materials used. And the guys operating the trucks now know exactly how much material they have left and where the next load is coming from. This is the kind of value the Internet of Things is really all about at the end of the day. And when we look at construction, we see a lot of firms today working on complex and congested layouts that require close coordination in real time. McCarthy Construction, they realized that in order to deal with this, they needed all their partners and employees to be able to work on multiple projects regardless of their location. In other words, they just realized that a new level of coordination and collaboration is central to their success. So, they're currently working on the Odyssey Aquarium in Arizona. It's a mammoth facility. 200,000 square feet, 3 levels. It'll contain 12,300 cubic yards of concrete and 2 million pounds of structural steel. Now, in the beginning, they knew they'd need to coordinate with the structural design team as well as with a multitude of trades, all of whom are in different offices throughout the southeast part of the US. And of course, the cloud was the answer for this challenge. They implemented collaboration for Revit, and it changed everything for them. Communication was constant, making information readily available. The cloud allowed them to reduce their turnaround time by more than 35%. In fact, the team worked together so efficiently that the project's permit drawings were as coordinated as the final construction documentation set. And for those of you who don't know, this is a huge deal. They're saving hundreds of hours in an industry known to chronically miss schedules. They were also an early adopter of our BIM 360 field software, and they've estimated it is saving them 17,000 man-hours. Unbelievable numbers. And here's a way that design, make, and use are playing out in a totally different way and positively impacting hundreds of thousands of people. You see, even though more than half the world's arable land is here in Africa, the majority of the small-scale farmers here rely on rain to water their crops. And that means they grow crops in just 2 periods each year. But most of these farmers, 60% of which are women, have land that could support farming and generate income and food year-round, if only they had access to irrigation technology. This is where Kickstart International's water pumps come in. You see, Kickstart's vision is to take millions of people out of poverty sustainably and permanently. The organization is a grantee of the Autodesk Foundation, and they use our tools to design and engineer their products. And you're going to hear a little more about the Autodesk Foundation later this morning. Now, Kickstart's human-powered irrigation pumps, they're available to farmers starting at about $70 US at local private sector markets in 16 different African countries. Kickstart's design team, they're based in Nairobi. They joined us last year at our Pier 9 fabrication facility in San Francisco, California. And they learned to use tools such as AutoCAD, simulation mechanical, and to design, test, and fabricate new components for their pumps. And after 3 weeks, they went back to Kenya with new skills and a new network of collaborators at their fingertips. The newest version of their Moneymaker pump is now for sale, and families across the region are using it to irrigate their crops during the dry season. Amazing. Last year here in South Africa, we talked with you a little bit about generative design. And of course, generative design uses algorithms to synthesize geometry. All it needs are your goals and constraints as input. Now, this approach allows computers to go off and explore an entire solution space and come back with ideas that we by ourselves could never have imagined. What I'm most excited about right now is that generatively designed things are making their way into the real world. We're going to share with you today some generative design work that we've been doing in partnership with Airbus for the last 5 years. Back in 2011, Airbus shared their vision for the future of flight for 2050. Now, this concept plane is still a little ways off, but we've been busy developing the technology and techniques to make it real. The first component that we've been working on is this partition panel. It divides the cabin and supports the jump seats where the flight attendants sit during takeoff and landing. Now, the current design of the partition, which has been flying in the Airbus A320 successfully for decades, it's strong and lightweight and made of modern honeycomb composite materials. And there's nothing wrong with it. But clearly, Airbus isn't interested in what's merely good enough. They want to explore the limits of what's possible. So they gave our algorithm the performance goals and constraints for this partition, and it returned tens of thousands of options that fully met these goals. Then, through a collaborative back and forth between the human design team and the computers, an optimal design was chosen. And this is Airbus's Bionic partition. It weighs half as much as the original, and yet it's even stronger. And each partition installed in an A320 is going to save 25 kilos in weight. Imagine the impact of redesigning an entire cabin this way for every single Airbus A320. Airbus, they estimate that this will save about 500,000 metric tons of CO2 each year. That's like removing 96,000 passenger cars off the road. This new partition is now being tested for flight readiness, including a crash test. This all sounds like it's still in the future, but it's not. The plane you fly to AU South Africa in next year could very well have this bionic partition in it. Here's another example of generative design in action. In 1996, Under Armour broke into the athletic market by reinventing the humble t-shirt. And now they are a powerhouse brand. Under Armour is pushing the boundaries of high-performance athletic gear. As the company approached its 20th anniversary, they looked to up the ante in the brand's performance training footwear. And so their innovation team wanted to design a lightweight, highly stable, and cushioning shoe to support athletes during the most intense workouts. So they created the UA Architect, the world's first 3D printed, commercially available trainer. Autodesk software was critical to the team at Under Armour in achieving some of the key goals for this shoe. Autodesk Fusion 360 software was integral to the shoe's development and refinement, and Autodesk Within was used to generatively design the lattice midsole for the stable heel structure with the appropriate elements of cushioning specifically for strength training. And the tool created a form so complex that the only way to manufacture it was to 3D print it. Well, all these examples we've shared have focused on the process of design, make, and use. But when the cycle repeats on itself, things get a little crazy in a good way. You see, the use phase can be transformative when you add many sensors in with the things you make. It's like giving those things a nervous system, so it can provide all the necessary data directly to the design. Now, you heard Jeff talk about this, our CTO, in that opening video. I'm going to repeat this story for you here. You see, we've been working with the Hack Rod team in LA, and they do stuntmen, and they make record-breaking cars, and they have several Guinness World Records, as you heard Jeff say. And we've been working with them to build a car with a nervous system. It is a traditional race car chassis, but it's been instrumented with dozens of sensors throughout. And we put that driver behind it, we took it out to the desert, and we really pushed that thing. We recorded all of the forces that it was being subjected to. And we got so much data from this new nervous system. It was incredible. We were able to plug it in directly to our generative design technologies, specifically one called Dreamcatcher. And what you get when you give a design tool a nervous system in the real world and you ask it to build an ultimate race car chassis, you get something like this. Something that's, as Jeff said, impossible for a human to have designed, yet a human did design it, but only then when they were augmented by generative design using that digital nervous system. So many uses for this incredible technology. Well, the present is rapidly changing and the future is clearly upon us. Autodesk has been guiding you through periods of significant technological disruption for well over 30 years now. And honestly, no company is better positioned or equipped to exploit the opportunities of this next age of innovation we're all living in today. And so whether you're a global enterprise, a student with a dream, or even a relief organization trying to lift a community out of poverty, we're going to be there to provide the advanced tools that are going to enable you, no matter what your challenge or goal, to work precisely in a manner that best suits your needs and provides you with the opportunities to flourish in this new age of connection. It's a future of making things. Okay, I hope you're inspired to think about how these technologies can help you as you build the future, because you're the ones absolutely doing it. Thank you so much for joining us here today, AU, and have a great day today. Thank you.